Okay, here's our last problem. I really like this problem. So I've changed the numbers from your homework, but it's really similar. So you're going to select an O2 series deep groove ball bearing rated for 1,000,000 cycles to support a 4,000 Newton radial and 2,000 Newton thrust loads on a shaft rotating at 1,200 RPM with light to moderate impact, designed for 7,500 hours with a total reliability of 95%. So you're going to need to iterate to find the bearing. And as you know, I love processes of iteration because I think they're so interesting, especially when we have designed really cool tools to help us with that process. So your hint is to start with the bearing size for the listed radial load. So check to see if that bearing meets the requirements. If not, you're gonna iterate from there. So what I mean by that is use this 4,000 Newton radial load as your FD. So start with FD equals FR equals 4,000 newtons. I'll show you in my analysis tool in a second. Application factor is 1.5. You can look at the table to verify. The hours desired, 7,500. Speed desired, 1,200. Reliability desired, 0.95. So this step is nothing new. So go to my analysis tool. And I have that entered in already. So 1.5, and notice that I'm using the 4,000 newtons as the load desired, hours, speed, reliability, rated life. Again, since you are told to use the, actually you're not told to use any table, but the only tables we have in Shigley are given for bearings with a rated life of 1,000,000 revolutions. So you can assume it's 1,000,000 for your homework. Okay, so what we get is a C10 of 57,648 newtons. So that is shown here. Now we need to go to the bearing table and look at a particular bearing. So we need a bearing that has a listed catalog load rating of slightly above 57.6 kilonewtons. So it looks like it would be an O2 70 millimeter. So the C10 is 61.8 kilonewtons, and then we also need the static load rating. So the C0, 37.5 kilonewtons. Okay, so these two values, it's going to be the same process for your homework. Now you're going to go to that newer section of your bearing sheet that you developed for KQ08. Okay, this is the fun part. So you're going to enter in the loads that you actually have. We have 4,000 newtons radial, 2,000 thrust, inner ring rotating, doom, doom. So C0, I had entered that in earlier, but you had put in your C0, so it's 37.5 kilonewtons, 37,500 newtons, so put that in, and it's going to spit out an FA over C0 value of 0.0533. So you zip down to the table. I like to draw this little box so I don't lose where I am in the table. So our FA over C0 value is between these two tabulated values, 0.042 and 0.056. So our E is somewhere in between 0.24 and 0.26. Again, you don't really need to interpolate here. You can just put a number in between. So 0.25, that means that the I is 2, and hence we're going to be using the X2, Y2 constants, meaning that the thrust load does matter. Okay, so our Xi is X2, so that is that shows up automatically in my tool. Let's use that calculator that I like to iterate to find Y2. Okay, our FA over C naught value is 0.0533, and that's in between 0.042 and 0.056. So those go in our X. And then the Y2 tabulated value 1.85 corresponds to 0.042 and 1.71 corresponds to 0.056. So I am just going to linearly interpolate for this middle Y value, 1.737. So let's drop that in there, 1.737. We get an FE, so the equivalent radial load of 5,714. Okay, so here is the trick. Now you're going to use this equivalent radial load as the FD in equation 1110. So instead of 4,000, I'm going to plug in 5,714. So we're in newtons there. Everything else stays the same. Our C10 is 82,350. So let's write that down. So here to summarize, using Fe equals 5,714 kilonewtons, we get a C10 of 82.4 kilonewtons. So what was the C10 of the bearing we started with? It is not large enough, so it doesn't have a high enough catalog load rating to withstand this equivalent radial load of 5,714 newtons. So this means you have to iterate. So the C10 of, we'll call this like the first iteration bearing, equals 61.8 kilonewtons, and that is smaller than 82.4 kilonewtons. So we need a higher capacity bearing. So then what would you do? You would go back to the table. So we started with an 0270 millimeter, and we have to get up closer to the 80s. So I wouldn't try an 0275. I don't think that would work. I don't know if an 0280 would work. I would try this 0285. So use the C naught of 53 kilonewtons and do the same procedure over again and see if you wind up with the C10 that is less than 83.2. If you end up with the C10 that is less than 83.2, it means that an 0285 millimeter bearing would meet capacity. Okay, love this type of problem. This is what would show up on the midterm. Love this problem. These are the types of kind of creative solving approaches that you might find on the midterm, and if not the midterm, definitely by the final exam. So I hope you get excited about it too. Bye.